Good morning to all of you. Is my voice is audible? Yes, Vijay, if my voice is audible.
Yes, sir.
Okay, so wait for a minute. So let me revise say the attendance code. तो स्कैन कर लीजिए अटेंडेंस के लिए. So what we have discussed yesterday. कल क्या पढ़ रहे थे? Yes. कल
Different transformation techniques, Fourier and all.
पढ़ रहे थे इमेज ट्रांसफॉर्मेशन. ठीक है. तो कोई बता दो जल्दी से इमेज ट्रांसफॉर्मेशन क्या होता है? What is the actual definition or actual meaning of image transformation? Yes. Image transformation क्या होता है? What is image transformation? It is nothing but a mathematical tool. Okay. So whenever I say we are performing certain image transformation, so it's nothing but we are performing a certain mathematical tool which convert from one domain. The image will be converted from one domain to another domain. Okay. Basically हम लोग बोलेंगे टाइम डोमेन या फिर स्पेशल डोमेन से हम लोग फ्रीक्वेंसी डोमेन में चेंज करते हैं इमेज को. That is called image transformation. Fine. So what is image transformation? Nothing but transforming the image from one particular domain, that is a special domain, to the frequency domain में जो हम लोग चेंज करते हैं उसको हम लोग बोलते हैं image transformation. Fine. So what is the need for image transformation? What is the major need? So most of your pre-processing जितने भी करते हैं, like whether it is you perform the filtering or perform the grooming of blur or enhancing the image. Okay, whatever you will do, now image transformation play a vital role. Apart from that, uh, it also compress the image. Okay, so whenever we need to transmit the data, whenever we need to transmit the data at low bandwidth, तो क्या करता है? इमेज कंप्रेशन के लिए भी आपका इमेज ट्रांसफॉर्मेशन बहुत यूजफुल है. फाइन. उसके अलावा आपका इमेज ट्रांसफॉर्मेशन क्या बेनिफिट करता है? टू एक्सट्रैक्ट द मोर इंफॉर्मेशन फ्रॉम द इमेज. ओके, या फिर फीचर एक्सट्रैक्शन के लिए भी हम लोग इसको बेटरली यूज कर सकते हैं. ठीक है, लाइक आइडेंटिफाइंग द रीजन और आइडेंटिफाइंग द बाउंड्री. दिस आर द सम मेजर एप्लीकेशंस व्हाई वी नीड टू परफॉर्म एन इमेज ट्रांसफॉर्मेशन. ठीक है. उसके बाद हम लोगों ने देखा था कि डिफरेंट टाइप्स ऑफ दिस प्रोसेस, पर्टिकुलर प्रोसेस क्या होता है. सो वी विल प्रोवाइड, सो आई विल प्रोवाइड एन इनपुट इमेज, सो आई विल परफॉर्म ए ट्रांसफॉर्मेशन. ओके, कुछ ट्रांसफॉर्मेशन टेक्निक रहते हैं यहाँ पर बेस्ड ऑन योर सिग्नल. ओके, ऑर्थोगोनल सिग्नल है या नॉन ऑर्थोगोनल सिग्नल है. ठीक है. तो बेस्ड ऑन दिस वी विल परफॉर्म सर्टेन ट्रांसफॉर्मेशन. बेसिकली आपके कोर्स में है फोरियर ट्रांसफॉर्मेशन, cosine, discrete transformation and Veblen transformation. Okay, so this three transformation we perform. So now P of UV is your what? Transform image. Okay, which is in frequency domain. Now I will perform certain operation here. So whatever operation you want to perform. So once you perform the operation, now again you have to perform the reverse transformation. So why we are performing the reverse transformation? So whenever you perform the reverse transformation, you will get back the image. So important thing to be noted here, the size of the image will not change. Okay. So whatever the original image size, that is suppose it's n cross n, the after transformation, okay, after transformation and regenerating the image by using the image reverse transformation, the size will be same. Okay, the size will not be different, but the number पिक्सल जितने थे वो सेम रहेंगे. Maybe some property will be changed, but the size will not be changed. Fine. So this is a basic idea of how we transform the image. Okay. So we already discussed. So then we have discussed some of the different image transformation technique that can be divided into different categories based on the signal. If it's orthogonal, sinusoidal signal. Okay. Then these are the categories. For non-sinusoidal, orthogonal, these are the categories. And for the basic function depend upon the static of the input signal. These are the different methods are used. And for directional transformation, these are different methods are used. The one thing you have to remember here, what is the basis function? Basis functions are nothing but you can say the smallest individual signal. Okay. Suppose हम लोग अगर इस साइन ओमेगा टी का बनाते हैं, ठीक है, साइन ओमेगा टी को कंस्ट्रक्ट करते हैं. नाउ साइन ओमेगा टी को बनाने के लिए इस नथिंग बट इसका बेसिक सिग्नल क्या होगा, इसका जो साइन ओमेगा होगा इसका बेसिक सिग्नल बनेगा, बिकॉज दिस इज द स्मॉलेस्ट सिग्नल विच आई कैन जनरेट और विच इज प्री डिफाइंड. Okay, so from this sin omega, what I will do, I will modify or multiply the amplitude so that I will generate the sin omega, sin 3 omega. So basic signals are nothing but the smallest basic or we can say building predefined signal which is used to generate other. While combining this basic signal, okay, by combining this basic signal, we will able to find the other signal or we will able to generate the other signal. Okay, so these are some introduction part of the what your image transformation. Okay, so today we will going to learn the very first transformation, which is your Fourier transformation. Okay, Fourier transformation. पहला जो transformation था Fourier transformation. So this is the orthogonal sinusoidal signal. So what the Fourier signals say, Fourier transformation say. So if I assume that now I am saying f of x is your one dimensional. Okay, if I am saying f of x is a one dimensional continuous signal. Okay, if I am saying, so what is f of x? Small f of x is nothing but your one dimensional continuous signal. Now suppose if I draw this signal, suppose I am drawing in x axis or x direction. Okay, now suppose the signal is something. Fine. Now this is my continuous signal f of x. Okay, so it's Fourier transformation of this signal f of x. Okay, so Fourier transformation of this signal f of x is denoted by capital F of u. ठीक है, डिफरेंट बुक में डिफरेंट नोटेशन दिया है. किसी किसी बुक में f of ओमेगा है, किसी किसी बुक में j ओमेगा है. फाइन, so don't confuse. Okay, different books are using different notation. Clear? Is this point is clear? अगर आप किसी दूसरे बुक में फॉलो करोगे, the notation may be changed. It may be written f of t and this may be written f of omega. Or sometimes they will write f of j omega. Okay, and sometimes they write other symbol instead of u. So just remember, this symbol represents your Fourier transformation of signal, which is given by the mathematical formula, which is nothing but integration over minus infinity to infinity f of x, okay, e to the power of minus j 2 pi ux dx. Right? So this is the Fourier transformation. Now the f of capital F of t is a Fourier transformation, and it's mathematically represented by this one. Okay, so you can easily assume that now this, or we can easily say this is a complex function. Yes or no? What is a complex function? Because we are having an imaginary number. If you expand this one, okay, based on if I say j omega according to the unit function, if I expand j omega, what will be there? It will be cos of omega plus j of sin omega. Yes or no? So what is this? This is a basically an imaginary function. ओके, ये जो आपका है, आपका याद रखना, ये जो फंक्शन है, ये जो एफ ऑफ यू होगा हमेशा एक इमेजिनरी फंक्शन होगा. फाइन, व्हाई इट इज इमेजिनरी? बट दिस पार्ट, इफ यू एक्सपेंड दिस पार्ट, अगर इस पार्ट को एक्सपेंड करेंगे, सो इट विल बी अकॉर्डिंग टू द यूनिट्स फॉर्मूला, इट विल बी समथिंग cos ओमेगा प्लस j sin ओमेगा. फाइन, सिमिलरली if I want to find the inverse of this transformation, okay, I can say inverse of Fourier transformation. Okay, so what the inverse of Fourier transformation gives? The inverse of Fourier transformation will give the actual signal, which is your f of x. Now this small f of x can be obtained. So why we need to inverse transformation? क्योंकि जो भी आप कन्वर्ट करोगे फ्रीक्वेंसी डोमेन में, फिर से आपको इनवर्स ट्रांसफॉर्मेशन परफॉर्म करना है ताकि आप एक्चुअल इमेज और भी कैन से डिजिटल इमेज को रिट्रीव कर पाओ. इसलिए हम लोग को इनवर्स ट्रांसफॉर्मेशन हमेशा जरूरी होता है. ठीक है. इफ दिस इज अ Fourier transformation equation, then what is the inverse transformation? A small f of x, that means the signal can be regenerated, then it will be integrated over minus infinity to infinity. Now it will be capital U, then e to the power of j 2 pi x u d. Fine. Again, this is a complex system. We can be represented in this format. Fine. Clear? Now, point to be noted here. Okay. Now, this x should be continuous and integrable at each point. Okay. X f of x क्या होना चाहिए? एक तो आपका फर्स्ट कंटिन्यूस होना चाहिए और ये फंक्शन को हर एक जगह में आप इंटीग्रेट कर पाना चाहिए. Similarly, आपका इसके लिए भी सेम कंडीशन. This f of u should be continuous and it should be integrable at every point. Then only these two valid equation. This two is your valid equation. Otherwise, we cannot convert. We cannot convert the time signal or one-dimensional continuous signal to the Fourier or frequency domain. Okay, basically what we'll do now, this time signal or time domain signal is converted into the frequency domain. When we are converting this f of x to f of u, that means we are converting from time domain to the frequency domain. Fine. So is it clear to all of you? Any doubt? Any doubt? So do make a note of these two equations. Okay. There is a Fourier transformation of the signal f of x, which is in one dimension. Okay, 1D continuous signal. Fine. So what we are actually doing now, we are converting this time domain to the frequency domain. Fine. So if it is clear, so let's move on. So now this equation can also be represented as, so what I actually said, already said. Now this is a complex equation. So now if it is a complex equation, so I can represent yeah. So if it is a complex equation, so I can represent this equation in this mathematical functions also. So f of capital F of u can be given as r of u plus j I of u. Right, where r of u is nothing but your real part of this function and I of u is nothing but an imaginary part of this function. Fine. So what happened? The same function can be represented. Same function, this one, I can represent in two parts. One is real part and other one is your imaginary part. Or this also can be represented or can be written as mod of f of u, fine, mod of f of u e to the power of j by u. Okay, so now this is an equivalent representation. Fine. So same function can be represented in this manner, real and imaginary manner, or it can be also represented as mod of f of u and e to the power of minus j by u. Now in this case, the mod f is called your frequency spectrum or Fourier spectrum बोलते हैं या Fourier magnitude बोलते हैं. What the mod f is called? Mod f is called your Fourier spectrum or Fourier magnitude. Fine. And it is given by the expression. How to find the mod of f? Now it is nothing but root over r of u square plus I of u the square. Fine. This is the formula to find mod of u. Sorry, mod of f. It is called Fourier spectrum बोलते हैं. क्या बोलते हैं इसको? Fourier spectrum बोलते हैं. या फिर something. Sometime we will call Fourier magnitude. Fine. Similarly, I can define the angle theta here. I can also define the angle theta, which is called your phase angle. Okay. So what the angle theta denote? Angle theta is your phase angle बोलते हैं. Okay. Okay. Phase angle बोलते हैं. Now it is given as tan inverse. It is given as tan inverse I of u by r of fine. So what happened actually? So whenever you convert any signal from frequency domain to time domain to frequency domain, so basically it will be converted into two formats. Basically it will be converted into two formats. The first one will be in your Fourier spectrum or magnitude spectrum. Second one, it is in the form of phase angle. So it will convert in the term of phase angle. Okay, there is one more thing called power spectrum, which is nothing but your mod of f the whole square. So it will take the square of this. Now this is called power spectrum. Okay, power spectrum, which is represented by P of u. Okay, P of u, which is given by nothing but R of u the whole square, fine, plus I of u the whole square. Now these three terms you have to remember because we are basically going to use these three terms. Okay, one is your Fourier spectrum, which is nothing but mod f, which is nothing but root over real part का square plus imaginary part का square. Second is your phase angle बोलते हैं. What we call? It is called phase angle, which is nothing but phi. Okay, which is given tan inverse imaginary part by real part. Then finally your power spectrum बोलते हैं, which is nothing but mod of f का whole square, which is represented by P of u, and it is given by this formula. Fine. So this is another type of representation. Same Fourier transformation can be represented in its magnitude as well as in its phase angle. Fine. Clear? Is it clear to all of you? Now, because we will going to use only this part only. Okay. With the help of the spectrum, Fourier spectrum, and phase angle, we will going to analyze. Fine. Any doubt? Yes. Any doubt? Anyone have any doubt? Okay. So we will continue. So now you can see what we have already discussed. Now this is mod f is called your magnitude of spectrum, which is given by this equation. This is called your phase angle or phase spectrum, which is nothing but P of phi of u, which is nothing but tan inverse imaginary part by real part, and there is a power spectrum or spectrum density, which is given by this one. Fine. Now suppose if now this is something about a continuous signal. Okay? Now what we are interested in discontinuous signal, because we know that when we going to store the image in our digital computer, the image is stored in which format? Whether it is going to store in continuous format or discontinuous format or discrete format. तो जब भी हम लोग इमेज को स्टोर करते हैं, ठीक है, इमेज को जब स्टोर करते हैं डिजिटल कंप्यूटर में, हम लोग ने पढ़ा था क्या स्टोर करते हैं? इट इज स्टोर इन एफ ऑफ एक्स वाई मैनर, व्हिच विल बी इन discontinuous manner, discrete manner में स्टोर करते हैं. So we will now discuss what is discrete Fourier transformer. What is discrete Fourier transformer? Now suppose same you could consider now f of x. Suppose now f of x is your what? Discrete signal. Okay, f of x is discrete signal. If f of x is discrete signal, now capital F of u will be your discrete Fourier transformer. Okay, discrete Fourier transformer. Now again remember we are talking about only one directional. We are talking about only one direction. But how the image is stored actually? When I was taking an image, now it is f of xy. Basically, image is stored in your two-dimensional discrete सिग्नल. ओके, जब इमेज को स्टोर करते हैं हम लोग हमेशा हम लोग टू डायमेंशनल डिस्ट्रिक्ट सिग्नल के फॉर्मेट में स्टोर करते हैं. फाइन. सो फर्स्ट वी विल डिस्कस द वन डायमेंशनल डिस्ट्रिक्ट Fourier transformer, then we will go for the two dimensional discrete Fourier transformer. So same condition, if f of x represent your discrete Fourier signal or one dimensional discrete Fourier signal, then f of u will be your discrete Fourier transformer, which is nothing but यहाँ पर आपका भी समेशन हो जाता है. समेशन ऑफ नाउ x equal to 0 to I will take n minus 1. Now what will happen if it is discrete? Okay, if it is discrete, then what will happen? Now its value ranges from 0 to, suppose I am saying size is n. Okay, size of the this axis is n. So what are the range? Range will be 0 to n minus 1 summation of f of x e to the power of minus j 2 pi capital N ux. Fine. Where u is your value ranges from 0, 1, 2, 3 like n minus 1. Clear? So why it is ranging from 0, 1, 2 like n minus 1? Because now this is a discrete format. This is a discrete format. Fine. So do remember this formula. Now what is this? F of x, small f of x is here. What is small f of x? Small f of x is your one-dimensional discrete signal. Okay. Then f of u is your will be your discrete Fourier transformer. Now what is the mathematical formula? Now, this is the mathematical formula which can be represented. Which is nothing but summation of x equal to 0 to n minus 1 f of x into e to the power of minus j 2 pi n ux, where u ranges from 0, 1 to like 2. Similarly, how to get the inverse of this? Now inverse discrete Fourier transformer, which is represented by IDFT. Okay, IDFT. Now it can be said DFT, discrete Fourier transform. Fine. So IDFT can be represented as, so whenever we perform the IDFT, so it will give the original signal in terms of f of x, which is nothing but 1 upon n summation of u equal to 0 to n minus 1 f of u e to the power of j into 2 pi n by ux. Now where x varies from 0, 1, 2 like that n minus 1. Okay. Now again same whatever we discussed previous one. Now again this is an imaginary function. If it is an imaginary function, I can represent f of u in two parts. Yes or no? So one is your real part and other one will be your imaginary part. Is it correct? So what we have discussed in कंटिन्यूस. ओके, जो कंटिन्यूस में पढ़े यहाँ पर भी सेम रहेगा. तो ये कॉम्प्लेक्स फंक्शन है. अगर कॉम्प्लेक्स फंक्शन है तो इसको दो पार्ट में रिप्रेजेंट करेंगे. एक आपका रियल पार्ट, ये आपका इमेजिनरी पार्ट. और आई कैन रिप्रेजेंट दिस एज ए मॉड ऑफ एफ e to the power of minus j 5u. Okay, where mod f is nothing but your magnitude or spectra or Fourier spectrum, which is nothing but it is root over of this square plus root over of this square. ठीक है. सिमिलरली फेस एंगल क्या होगा आपका? फेस एंगल भी सेम होगा. इट विल बी tan inverse what imaginary part I of u by r of u. Similarly, power spectrum is given by your r of u square plus I of u square. Okay, is it clear to all of you? So we have discussed the Fourier transformer with respect to continuous signal and with respect to the discrete signal. Fine. So there is slight changes in between two. Now this magnitude power spectrum formula will be same. So what are the changes? Changes will be in case of continuous. Now we have the continuous integral from minus infinity to infinity. But in case of discrete, now it will be continuous summation. Discrete is nothing but continuous summation of discrete signals. Okay, Fourier discrete transform is nothing but continuous summation of discrete signal. Similarly, we can uh, perform IDFT equals discrete Fourier transformation to generate or to get the original function upon that. This is the formula. Fine. So let us understand with the help of the example. Now it's further clear to you. So do remember the formula because we are going to use this formula. Okay, formula yaad rakhna, especially about magnitude spectrum and phase spectrum. Okay, again same thing what I discussed. The f of u can be represented in complex part and imaginary part, or it also can be represented in polar format. Okay, polar expression. Then your magnitude spectrum will be same and phase angle will be same, tan inverse, and power spectrum will be same. Now let me take an example. So now suppose this is your discrete signal is given. Okay, now this is my discrete signal. So what is signal? F of x is 2, 3, 4, 4. That means now suppose this is my coordinate axis. Suppose this is x. Okay. Now suppose these are coordinates. Suppose this is 0, this is 1, this is 2, this is 3. So how the signal will be represented here? Now the signal f of 0. Now this will be f of 0. This is f of 1, f of 2, f of 3. Now what is the value of f1? F of 1 is, suppose this is my 1, this is 2, this is 3, this is 4. Okay. Now what is f of 1? F of 1 is 2. Now it will be present line here. Now what is f of 1? F of 1 is 3. Now the straight line. What is f of 2? F of 2 is your 4. Straight line. Now what is f of 4? Now this is f of 4. Now this is f of x representation. Now this graph represents f of x. Fine. Yes, समझ में आया? तो ये क्या है आपका? ये f of 0 वैल्यू है, f of 1 वैल्यू है, सॉरी 1 है, ये f of 2 का वैल्यू है, ये f of 3 का वैल्यू. अगर हम इसको ग्राफ में रिप्रेजेंट करेंगे तो इट विल बी रिप्रेजेंटेड लाइक दैट. f of 0 will be 1, f of 1 will be 3, f of 2 will be 4, f of 3 will be 4. Now this is a discrete representation of one-dimensional signal. Now what I have to do? I have to find the DFT or discrete Fourier transform. Okay. So what is the f of u formula? So f of u. So what is the formula of f of u? So if you remember, f of u is nothing but I have to perform summation of x equal to 0 to कहाँ तक करना है? n minus 1 तक करना है. Now it will be f of x into क्या था? e to power of minus j 2 pi capital N x u, where u is varying from 0, 1, 2 like that and minus 1. The same thing I am doing. So first I am finding f of 0. Okay, first I am finding f of 0. So same thing, it will vary from 0 to, so f of 0 निकाल रहे पहले. क्या निकाल रहे? u की जगह 0 ले रहे. u की जगह first u equal to 0 के लिए फाइंड कर रहे हैं. So f of 0, it will vary from x varies from 0 to 3 n minus. Now this is your n. Okay, this is your n equal to 4, number of elements. So it will be 0 to 3, f of x into, now if it is u equal to 0, is everything will be 0. That's the reason I am writing e to power of 0, which is f of x. Now it will be 0, this condition 0. Now it will be, so when you continue summation this one, it will be f of 0, f of 1, f of 2, f of 3. That is nothing but 2 plus, okay, 3 plus 4 plus 4, which is nothing but your 13. Clear? Similarly, f of 1 जब निकालोगे, now this is the expression for f of 1. So it is f of x into e to the power of minus j 2 pi x by 4. ठीक है? जब आप u का वैल्यू देंगे क्या देंगे? 1 देंगे और n का वैल्यू क्या है? 4 है, इसलिए माइनस j 2 pi 4 हो गया. तब इसको आप एक्सपेंड करोगे तो इट विल बी 2 e to power of 0, 3 e to power of this much, 4 e to power of this much, 4 e to power of this much. जब इसको सॉल्व करेंगे this will be the value. Fine? Clear? Similarly, when I have to find f of 2, which value is minus 1. Similarly, I have to find the f of 3. Clear? तो हम लोगों ने क्या किया? u equal to 0 के लिए फाइंड किया. This is u equal to 0. Now u equal to 1 के लिए फाइंड किया फोरियर ट्रांसफॉर्मर. Now u equal to 3 के लिए फाइंड किया, u equal to 4 के लिए फाइंड किया. Fine. Now what are these? These are the frequency domain. Now if I represent this one in a graphical manner, now let me show you. Let me clean this one. I hope it is clear to all of you how we are calculating. So this is a mathematical calculation. So what we have performed? So basically we have performed the mathematical calculation. Okay. So that will be giving क्या दे रहा है आपको? आपको Fourier transformation दे रहा है. ठीक है, for discrete signal. Yeah. So what happens? So once we calculated, now I can calculate the magnitude or Fourier spectrum for every value of u. Now f of mod of f0 will be 13. Similarly, mod of f1 will be root over 5. Then mod of 2 will be 1 and mod of 3 will be 5. So what are these values? These are the magnitude spectrum. These are the magnitude spectrum. Similarly, I will calculate the phase angle for the each value of u. So these are the phase spectrum or phase angle. ठीक है, तो जब हम इसको ड्रॉ करेंगे, ठीक है, अभी हम इसको ग्राफिकली रिप्रेजेंट कर रहे हैं. ऑल दैट थिंग आई एम रिप्रेजेंटिंग ग्राफिकल फॉर्मेट. ठीक है. Now this is the original signal f of x, है कि नहीं? f of x. So this is your f of x, which is equal to what are the values? Values are something 2, 3, 4, 4. Now this is your representation of frequency of, or I can say Fourier representation. Okay, Fourier discrete Fourier transformation representation of the signal f of x. Now this is your f of u. Fine. And this is your magnitude spectrum representation. This graph represents your magnitude spectrum. Okay. Why? Because we know that f of u का mod क्या था? Equal to 13. So this represents your f of u का mod, which is 13. Now similarly, f of 1 का mod क्या था? f of 1 का mod something I think. What is f of mod? It's root over 5. So no, it is root over 5. So it is presented by this. Similarly, this is 1, this is root over 5. So this is, what is this one? This particular represents the magnitude spectrum of the signal f of x. Similarly, what this represents? This represents your frequency, okay, or phase spectrum of the given signal f of x. Okay. Now this is not an image transformation. So what we are doing actually, we are representing this in graphical format. So when we will transform in 2 dimension, it will look something different. So is it any doubt regarding this? Because this is very important. If you don't understand the Fourier's one-dimensional discrete Fourier transformation, it will be difficult to understand 2 dimension, because images are stored in a 2 dimension. Okay, इमेज जितने भी हैं आपके 2 डायमेंशनल में स्टोर होते हैं. So is there any doubt? Anyone having any doubt? Any doubt? Okay, then so we will look at one more example then. If you are having no doubt, quickly complete me another example. Now this is second example. So if you want to convert the signal, okay. Suppose f of x is given, f of x is given something like it is 2, 4, 3, 7, 2, 7, 1, 2, 3, 4, 5, 6, 4. Now this is your f of x. Okay, this is the discrete signal. So what you have to do now, n is your equal to 7. और इसलिए f0 के लिए कैलकुलेट करना है, f1 के लिए कैलकुलेट करना है, f2 के लिए कैलकुलेट करना है. Now these are the values. These are the actual values for this, which is 20. Now this is minus 2 point something, minus 2.4 minus j into 0.1, and this is the value of f of 2. Okay. Now similarly, you have to find for f of 3, f of 4, f of 5, and f of 7. Now these are the values for the f of 3. This is the value for f of 4. Now this is the value for f of 5, and 6 and 7. So once you calculate this one, next what you have to do, you have to go for, now you have to go for the magnitude spectrum. So you have to find the value of magnitude spectrum, and you have to find the value of power spectrum while using that formula. Okay, what formula we use for magnitude spectrum? Now it will be nothing but what? Root over r of u root over u square plus I of u root over u square. Okay, fine. So similarly, I can find the phase angles. Okay, so once you find the magnitude spectrum and phase angle, now you can represent in graphical format. Now when you represent this graphical format, this is the actual signal. Okay, now you can analyze here. Now this is your actual signal. Okay, this is my actual Fourier distinct signal which we are having. Okay, now the signal is something f of x equal to, it will be 2, 3, 1, okay, 4, 5, now it is 0, and it is 2. But this actual signal is given, which is represented in this format. Now this is your Fourier distinct Fourier transformation, which is represented by f of u. Now I can see here, now the signal frequency are different. Okay, now the frequency are different here. And what this represent? This will represent your magnitude spectrum of f of u, and this represents your phase angle of f of u. Clear? So this is the second example. Now, if you take for different signal, you will get the different Fourier transformation of the frequency domain and different magnitude spectrum and different phase angle.